Hello. In this video, we're going to talk about how to use the product rule for derivatives. So far, we've looked at the power rule for derivatives. And if you remember, when you're given any expression that has a variable raised to a power, you differentiate, that means find the derivative of each term, by multiplying the old exponent, n, by the old coefficient, a, to get your new coefficient, and then you subtract 1 from your old exponent to get your new exponent. We're still going to need the power rule as we're working through and using the product rule as we differentiate or find the derivative of individual terms. So here's the product rule. The product rule takes a product of two or more, but we'll start with two, functions or factors. In this case, the two factors are f of x and g of x. And when you find the derivative using the product rule, you wind up with, instead of a product of two factors, you get a sum of two terms. There's two terms here. And each of the terms in your sum contains one of the original factors. In this case, the first term has f of x, the second term has g of x. And it also, each of the two terms contains one derivative of an original factor. The first term here has g prime of x, and the second term has f prime of x. So obviously you have to use derivative rules to find those g prime and f prime parts of these terms, but it's not that hard to do. It gets a little bit more difficult as your factors, your individual factors, become more complicated functions, but let's start off with an easy example just to show you how this works. If f of x equals x plus 5 times x plus 7, this one's easy enough to just distribute, use the FOIL method to multiply these two things out. If you do that, right, you'd get f of x equals x squared plus 12x plus 35, and then it's a simple power rule differentiation. You wind up with f prime of x equals 2x plus 12. However, because this function is written as a product of two factors, x plus 5 and x plus 7, I can apply the product rule here. So if I go to take the derivative, right, I have the original first factor times the derivative of the second factor. The derivative of x plus 7 would be 1. And then I add to that the original second factor, x plus 7, times the derivative of the first factor, x plus 5, which would also be 1. Now when I distribute those 1's and I add the x plus 5 and the x plus 7 together, I wind up with the same exact thing that I did by multiplying them out first. Now you'll have to assess each situation and see whether or not you want to multiply things first and just do the power rule, or you want to apply the product rule. Obviously, as the individual factors get more complicated, you're going to want to use the product rule to do this. So let's do another example here. All right, we have two factors here. They are negative x cubed, and then the second factor is 3x to the fourth minus 2. Now, very often it helps you to differentiate or find the derivative of the individual factors first. Just keep them in the margins of your paper. Right? The derivative of the first factor with respect to x, that's what that d over dx means, would be negative 3x squared. And the derivative of the second factor with respect to x would be 12x cubed. And now I just assemble the ingredients in the right format here. My derivative of y with respect to x would be the original first factor, negative x cubed, times the derivative of the second factor, 12x cubed, plus, now I switch to the second term of my sum. I have the original second factor, 3x to the fourth minus 2, times the derivative of the first factor, negative 3x squared. Now, as these things get more complicated, you don't necessarily have to go further to simplify them. This expression is technically the correct derivative of y with respect to x, even though it has not been put in simplest form. On delta math examples, they allow you to write in a derivative like this. But if we were to simplify this, if we were to distribute and combine any like terms, in the end we'd wind up with negative 21x to the sixth plus 6x squared. Let's try one more example. I think you'll have the hang of it. All right, our two factors here are the negative 2x to the fourth minus 3 and then negative 2x squared plus 1. So in the margins, I'm going to take the derivative of the first factor, and I get negative 8x cubed using the power rule. Then I'm going to take the derivative of the second factor. I get negative 4x. And now I'm going to assemble them in that product rule format. Right? It's original first factor times derivative of the second factor plus original second factor times derivative of the first factor. All right, again, that is a correct derivative. This is technically the derivative. The differentiation process is essentially done here. The only thing that you can do further than this is to clean it up a little bit and put it in simplest form. In this case, if you were to do that, distribute the negative 4x and the negative 8x cubed and then combine like terms, you'd wind up with this expression. So that's the product rule. Obviously, again, as the functions or the individual factors get more complicated, finding the derivatives of them becomes a little more complicated still, but the process does not change. It is still at its most basic level, right? An original factor times the derivative of the other factor plus the same exact format there where you switch the original and the derivative out. Okay? So use this to complete any product rule scenarios you see. And if you have any questions, as always, let me know.